You have stuff for me. To your left, please. I would like you to create a picture for me. Draw an area that this graph, this integral, represents. What's your picture look like? Talk to me. The graph of x squared is a parabola, and our 1 to 3 gives us, we're on the right side, and we're looking under the parabola between 1 and 3. So, really, I'm going to write this same integral. I'm just going to change it a little bit. The following is the exact same picture. Right? Subtracting 0 doesn't change diddly squat, does it? But let me go back to the Riemann sum for a second. Let me go back to the Riemann sum. We described the area by developing a rectangle and then adding up all the areas of those rectangles and letting the rectangles get more and more numerous and thus smaller and smaller, right? And I said, clearly we have a left side and a right side, and that was our xi star piece, and we had xi minus 1 and x and all that crap. And then we had a height, and the height was an f of x. But really, the height of a box is the difference from the top of the box to the bottom of the box. I just always assumed from our picture the bottom of the box was at 0. What if it isn't? Actually, scratch. Let's reverse that. Instead of thinking of this as a single function, I want to think of it as it's two separate functions. Graph each of these separately. On one set of axes. So instead of one graph here, I want two. So graph of y equals x. It's a straight line at an angle of 45 degrees. At x squared, that's the parabola we see above, right? If I asked you for the area cut off, bounded by these two curves, this little loon shape, how would I figure that out? I have lots of different methods to figure this out. But the one thing I need to start with, well, let's actually get back to that. I promise I'll get there from here. But I'm just going to look at these two for the moment. I'm going to end up here, but I'm not there yet. Before I actually figure out how to get that area, I need to know what its boundaries are. But I know the top is bounded by y equals x. And the bottom of that boundary is the y equals x squared. Where does this region start? Where does it end? I clearly only want that piece. I do need to find the intersection points. And I find the intersection points by asking where are these equal to each other. Where does that happen? I told you Parser would get back here. And then if I factor out an x, I get x minus 1 here. So either x is 0 or x is 1. Oh, there. If I do the integral from 0 to 1 of x squared, that would give me the stuff that's under the parabola above the x-axis. Right? That's what that integral represents. For that curve. If I did the integral from 0 to 1 of x, that would give me a triangle. But the thing I want is the area of this shape. How do I get this one from these? Subtract what from what? Aha. The area, if I overlaid these, then the area I want is that piece. It's the difference between these two areas, which makes it the integral of x dx from 0 to 1 minus the integral from 0 to 1 of x squared dx, which is exactly, because if I'm adding or subtracting with the same limits, I can combine these two integrals and just do one. But I can also think of my Riemann sum and my little boxes that I were going to add up, right? Let me go back to the original drawing we had. And instead of drawing my rectangle from y equals x all the way to the x-axis, let's just draw it from y equals x to y equals x squared. Now the height of the box doesn't go all the way to the x-axis, but the height of the box can still be determined by taking the top minus the bottom. It does help if I put the little star on the xi that's down there. I apologize. And if I say to myself, what I really want to do is I want to slice up this region, but instead of going all the way to the x-axis, I want to stop at that bottom curve. I'll still get the area, and the area will be the limit as n goes to infinity of the sum of all of the stupid little boxes, height. Wait a minute, height is now this expression. Times delta x. Top to bottom. If I start at a height of 7 foot and I go to a height of 4 feet, how far did I go? I went 7 minus 4. Top minus bottom. All I care about is that it's top minus bottom. That's a Riemann sum. And if I say, I don't want a Riemann sums suck, let's turn it into an integral, the integral of this is exactly this integral. And I can really say that this is my shortcut. As long as I remember that I'm looking between two curves, instead of going all the way to the x-axis, I can say my height is always going to be the top curve minus the bottom curve. As long as I know a left boundary, a right boundary, a bottom boundary, and a top boundary, I can find the area between those boundaries. So from A to B on the left, and from G of X on the bottom and F of X on the top, this is the area. Here's an explicit version. I want the area of the region bounded by y equals e to the x, y equals x equals 0, and x equals 2. Before we do a lick of calculation, a graph would be a lot of help. So I can tell you which one's on top and which one's on bottom in this section between 0 and 2. So draw me a picture. Since I only care what's going on between 0 and 2, I can adjust my window to only show me the x's around that interval. So I'm going to change my window a little. And that gives me a more close-up view of the piece of the picture I'm interested in. Which one's on top? E to the x, that's my curve. And there's my straight line y equals x. Even a crappy picture can be of help. R is the region in question. I drew a little r in it. But label it so we know what's going on. And then I can picture that little rectangle. Somewhere in here, there's my little thin rectangle. Yes? I just drew it as a little vertical strip. top minus bottom with respect to x from left to right. The area of the region R, the interval from 0 to 2, top minus bottom. Yes, because I just said bounded by, and that's why I gave you a left and a right edge. Start here, end here. So yes, if I wanted the whole area, it would be infinite, right? Because they're not intersecting. But I said, cut it off and give me the area of this piece. That's why I need a boundary to the left and the right. So tell me what you get. By the way, you're welcome to leave your answer in terms of E. But tell me what you get. I did something sneaky. I gave you an answer. When you plug in 0, you don't get 0. Plug in e to the 0, you get 1. Because it's x squared over 2, isn't it? Well, because I had to do the antiderivative. The antiderivative of e to the x is e to the x. But the antiderivative of x is 1/2 x squared. My power goes up. More questions, comments, screams at the void, whatever. If I don't give you a interval in terms of x, then I need to hope that these things cross, because I am still saying the region bounded by something. So I need a bounded piece somehow. This one's evil. There's my piece. That's my region bounded. I have this x to the fourth equation. It's kind of a fat flattened parabola. And then I have my 3x minus x cubed, my downward cubic here. So the cubic versus the degree 4 quartic, they do cross twice. How do I find those points? Make them equal to each other. X to the fourth equals 3x minus x cubed. Let's put it all on one side. I can factor out an x. So I am sure that one of these is x equals 0. But then I need to figure out where this thing is equal to 0. And again, I'm going to say a sentence you've heard me say a couple of times this semester. Do you know how to solve cubic equations? You have Torricelli's or Cardano's formula memorized. Me neither. I don't know how to solve this. I have absolutely no idea where this is equal to 0. Yes. Typo, -1 to me. Good catch. I still don't know how to solve it. What do I do now? I don't know how to solve it. But I can still find the x value where they cross. If I don't have an analytic method for doing this, I can at least get a numerical solution. And that's sufficient. Option number 5, I want to know where these two curves cross. The first curve is the x to the fourth curve, because that's the one labeled y1 in my list. Hit enter. See how it leaves a little mark on the curve? The second curve is the cubic equation. It went down to the next one in the list. I hit enter. And it says, okay, you see it left a little mark again. Little plus sign on the curve there. It says, give me a guess. Where do you think they cross? So I'm going to go over here and get close to where I think they cross and hit enter. And it's going to give me the number. 1.174559. How many decimal places do I need? It depends on the utility, right? What are the sig figs in the problem? I'm not a lab scientist. I know I don't even try and play one, but somebody somewhere is going to say, I'm sorry, this problem has 5 sig figs, you need 5. Or somewhere in the instructions. And for this particular problem, it says use 3 decimal places. So let's use 3. There you go. Now I know the integral I need to do. I need to do the integral from 0 to 1.175 of what? Top curve minus bottom curve. And in our case, the top curve in this section is the 3x minus x cubed. And I know how to do that. Antiderivative of 3x. Antiderivative of x cubed. And the antiderivative of x to the fourth. And I'm evaluating between these two numbers. This time when I put in 0, I get 0 and 0 and 0. So I'm okay with that part. But now everything else just goes right back into the calculator. The 3 decimal places, the answer is 1.146. By the way, if we were back on the graph and we found the intersection between these two curves, that number is stored in my calculator as x at the moment. It says x equals, right? So if I quit from this page and I just hit the x button, I could keep all the decimal places. And I could literally write 3x squared over 2 minus x to the 4th over 4 minus x to the 5th over 5. I don't need to copy down squat. It does kind of throw the sig figs out the window, though, because I've used all the decimal places in my interim calculations. Questions? All right, what have you just thrown at me here? There's my picture, right? Where do they cross? Oh, crap. It says explicitly in the problem, I want to go from x equals 0 to x equals 3. But they cross at 2. I got to split this into 2 pieces. Because which one's on top changes on the left side of 2 versus the right side of 2. So in order to find this area correctly, I'm not going to do one integral. I'm going to do 2, because they change roles. So really, I've got two areas. I've got this area, and I've got this area. And the curve that's on top in the left area is the one that's on bottom in the right area. All right, fine. I just need to know what goes inside each of those sets of parentheses. Which equation is which? And that makes this one the other one. And that means those two reverse roles in the second integral. So in the first integral, I have the integral from 0 to 2 of 8 minus x squared minus x squared dx. But in the second integral, say again? I absolutely, absolutely, absolutely need those parentheses. Otherwise, the x squareds cancel. And that's not what I want to do. If you automatically have done the distribution and you write x squared minus 8 plus x squared, that's fine. But you have to take that sign change into account. So over here, I have the integral from 0 to 2 of 8 minus 2x squared. And since they've reversed positions, I switch the signs. The second integral is 2x squared minus 8. They're the exact same equations. One is the negative of the other. Finish it out. Give me a number. Yes, no, maybe, kind of, possibly, sort of, who knows? Did I get anything right? Plug in 2, 16. 2 times 8 is 16 divided by 3. Plug in 0, they're all 0. Plug in 3. 3 to the third is 27. 2/3 of that is 18. 8 times 3 is 24. Plug in 2. I get the same numbers as here, just reversed. Common denominator, adding integers, common denominator. 48 minus 16 is 32. 16 minus 48 is negative 32, but there's another minus sign out there. Minus a minus is plus. 32 and 32 is 64. 6 times 3 is 18. Give me a common denominator. Questions? Again, my first request, draw me a picture. Yes, sir. That is x cubed. You'll probably want to zoom in near the origin to see what's going on a little better. But I've got a sine curve, wiggle back and forth, and then I've got a cubic equation, and they cross like that. Bleh. It doesn't say region. It just says find the area bounded by. There are 2 of them. But sine pi x is what kind of symmetry going on here? The sine curve has what kind of symmetry? It's an odd function. X cubed minus x is also an odd function. If I turn the picture upside down, it's the same bloody thing. It's symmetric. The stuff in the upper left is the same as the stuff in the bottom right. The stuff in the upper right is the same as the stuff in the bottom left. So this symmetry through the origin meant that if I tried to do it as one integral, what would I get? Because I'd be going from minus a to a. So I can't do it as one integral. You've got to do it as two separate integrals. But they're the same shape, aren't they? Do one of them and multiply by 2. Might as well make my life easy and do the one on the right. So I need to know where they cross. What's that spot? It's 1. I don't even have to do the work, remember? Second, calculate intersection. Yep, they cross at exactly 1. They also cross at exactly 0. So I'm going from 0 to 1, and I'm integrating and multiplying by 2. What's the integrand? It's the thing that goes here. And make sure you put those parentheses in there because I've got this compound thing being subtracted. I want to make sure I don't make a sign error. It's not just sine of x. I need a u sub for that part. I think it would be a wise maneuver. Since I don't need a u sub for the other part, let's separate this into 2 pieces. Hey, integral of top minus bottom. It can be 2 separate integrals instead of 1 integral. I do need a u substitution over in that left integral. U equals pi times x. Which means that du is pi times 1 times dx. Do I have a pi there? Not on the outside. Either mess with this or mess with this, your call. If I'm going to switch things, do you want to leave the limits in x or do you want to switch the limits to u? It's a definite integral. It's your choice. Switch it or leave it? Leave it? Okay. Then this becomes the integral from x equals 0 to x equals 1. Sine of u. I get a 1 over pi. I'm going to put that out front for the moment. Du minus the integral from 0 to 1, x cubed minus x dx. I've not actually done any antiderivatives yet. I've just done the setup with the u substitution. What's something whose derivative is sine u? The negative of the cosine. So I get minus 1 over pi cosine u evaluated x equals 0, x equals 1, minus, and now I do the antiderivatives over here. 1/4 x to the fourth minus 1/2 x squared, evaluated from 0 to 1. To me, this is the only acceptable way of having more than one letter in an integral problem ever in Calc 1. And that's when you got the limits in one variable and your evaluation in the other, because in order to plug in, I need to switch back. Here, if your integrand or your function is in a different variable, yes. I need to know that you did not just go ahead and plug in 1 and 0 for you. Now I can plug in and get numbers. Cosine of pi. What is cosine of pi? Cosine of pi is -1. Cosine of 0. Cosine of 0 is 1. Plug in 1. What's 1 to the fourth? What's 1 squared? Plug in 0, and you get 0. This is a -2, right? But it's multiplied by -1, so that's 2 over pi minus, well, that's 0, minus negative a fourth. And if you want, you can simplify that 4 over pi plus a half. If you really want, you give me a decimal. And then do the two integrals on the calculator and see if it works. Questions? Absolutely. Here? Absolutely. An inside and outside, yes. That's my whole goal of queuing up the identification of a U sub. Oh, it's not just function of X. It's function of stuff. One of the more important ideas that we kind of glossed over earlier is I said the letter we were using didn't really matter. When we were doing an integral, it could be the integral of x squared dx. It could be the integral of y squared dy. It could be the integral of z squared dz. It could be the integral of Fred squared dFred. I don't care what the variable is, it's a dummy. But when we interpret this as area, we've got a height and a width. I'm drawing that little rectangle. I'm adding it all up. What the hell is that? If I did square root it, I'd get a plus or a minus, wouldn't I? Oh. Wait a minute, that would give me 2 graphs instead of 1. And those graphs would look like what? One would be going up this way, the square root. The other one would be going to... I did this. I did this in pre-calc. I did this in trig. This is still a parabola. It just goes sideways instead of up and down. The y squared, the x isn't. It's going this way. Go back to our conic sections formula sheet that's on our Canvas page. We're going to ask for something. Okay. Good. But I can't actually graph this like that in the calculator. So let's graph it with the square root, the way you were suggesting, to get a picture. Graph this equation, that's easy. And then I'll graph the square root of 2x plus 6. And then I'll graph minus the square root of 2x plus 6. Ew. Clearly, I see an area that I want, right? Where do these cross? I actually think plugging it in is going to be easier. If I put this expression for y in here, I get x minus 1 squared equals 2x plus 6. X squared minus 2x plus 1 equals 2x plus 6. Move it over. I get x squared minus 4x minus 5 equals 0. Which factors? X minus 5, x plus 1. So these cross when x is negative 1 and when x is 5. Which, by the way, means I know the y values. But if I do the integral from negative 1 to 5, I have a problem. What problem do I have? This is further left. It's a lot easier to see over here. It's further left than that. Oop. It's not easier to see when it's over there, sorry. There. That point is clearly further left than this. But I know what that point is also. That point is x equals -3 because it's where y is equal to 0. And if I put in 0 here, 2x plus 6 equals 0 means x equals -3. Yeah, put them both in there. So really, I need to do two integrals. I need to do the integral that goes from -3 to -1. And then I need to do the integral that goes from -1 to 5. Between -3 and -1, what curve is on the top? What curve is that? It's the positive square root part, right? Because we're only looking at the upper curve. This is y equals root 2x plus 6. And down here, what's that curve? Ah, crap. Which means just for this part 1, region 1, I need to do the integral from -3 to 1, -3 to -1, of top minus bottom. And then to do the second region, I need to do the integral from -1 to 5 of the top curve, which is still this square root, minus the bottom one, which is this equation. That's less worse. This is disgusting. I hate this. I don't want to do this. Okay, everybody, tip your head. With your head tipped, you have a top curve and a bottom curve. I'll do it for you. Isn't that a prettier picture to work with? So what if instead of trying to do this as if my rectangles went from top to bottom, what if I turned the entire thing sideways and let my rectangles go horizontally? Same picture, but I'm going to draw the rectangles this way. So instead of thinking of my rectangles being stacked going from left to right, I think of my rectangles being stacked going up and down. Wait a minute. That means my width is a little bit going up and down. That's not dx anymore. That's dy. Because this is still the y-axis, and this is still the x-axis. But now instead of thinking of top and bottom, I'm going to think of right side and left side. And since positive numbers are over here on the right, where I did top minus bottom, I now do right minus left. Wait a minute, if I'm integrating in y, if this differential is dy, then I want everything in here in terms of y, not x. So it means the numbers are going to, instead of being the left end and the right end, they're going to be the bottom y value and the top y value. But that means I need to rewrite my equations. My equations cannot be written y in terms of x because the right end of this rectangle is an x value. I need to take that equation and rewrite it x in terms of y. So when I look at this right side equation, I want to write it x equals. What's the equation for that? X equals. I just solve for x instead. And then the left side. All right, well, I start with y squared equals 2x plus 6. I'll move the 6 over. And then I'll divide by 2. And I'll get x equals 1/2 y squared minus 3. And everything's now in terms of y. And I can think of my area as stacking those little rectangles the other way. Right minus left. There's one more thing I need to do. I need to know before I can actually do this integral. What's the one other thing I need to know? The bounds. But I know the bounds. Didn't we work out what those points were? I need the y values, not the x values. And this problem has no square roots, has no u substitution, and is only one integral. That's so much easier. Just turn your head. Some pictures are better off sideways. With a little bit of work, you should be able to get this answer because it's nothing more than polynomials. And that's easy. If I distribute the minus sign here, I'll have a minus 1/2 y squared. I'll have a plus 3. 1 plus 3 gives me the 4. The y stays positive. I just put it in descending order of powers. From here on down, this is a piece of cake. Where am I going to use crap like this? The following picture is called a pathogenesis curve. Congratulations, you have caught a disease. I hope it was fun catching it, but you caught something. Symptoms show up as your viral load increases. Your body begins to fight the infection. Your viral load continues to increase. You're at your maximum fighting. You are really sick, and then you start to get better, right? Your viral load decreases. How do antiviral drugs work? They artificially decrease your viral load. So let's suppose you start taking Paxlovid for COVID. It's going to cut off and decrease your viral load artificially. But the result is a decrease in viral infection. How much? It's the area between two curves. I'd love to tell you it's useless crap, but I just got an email from a student who has COVID. It's still out there, people. I'll see y'all tomorrow. Thank you.